This is problem J3 of the 2020 CCC contest solution. Let's start with the description. Ahima has been experimenting with a new style of art. She stands in front of a canvas and using her brush, flicks drops of paint onto the canvas. When she thinks she has created a masterpiece, she uses her 3D printer to print a frame to surround the canvas. Your job is to help Ahima by determining the coordinates of the smallest possible rectangular frame, such that each drop of paint lies inside the frame. Points on the frame are not considered inside the frame. The first line of input contains the number of drops of paint n, where 2 is less than or equal to n and 100 is greater than or equal to n. And n is an integer. Each of the next n lines contain exactly two positive integers, x and y, separated by 1 comma, no spaces. Each of these pairs of integers represents the coordinates of a drop of paint on the canvas. Assume that x is less than 100 and y is less than 100, and that there will be at least two distinct points. The coordinates 0, 0 represent the bottom left corner of the canvas. For 12 out of the 15 marks, x and y will be two-digit integers. Output two lines. Each line must contain exactly two non-negative integers separated by a single comma, no spaces. The first line represents the coordinates of the bottom left corner of the rectangular frame, and the second line represents the coordinates of the top right corner of the rectangular frame. So here we're given 5 sets of coordinates over here, and we are to output the bottom left corner and then the top right corner. So the bottom left corner is 23.9. Notice that if the bottom left corner is moved up, the paint drop at 64.10 will not be inside the frame, as it will be touching. If the corner is moved right, the paint drop at 24.78 will not be inside the frame. If the corner is moved down or left, the frame will be larger and no longer the smallest rectangle containing all the drops of paint. A similar argument can be made regarding the top right corner of the frame. So using this, let's construct a solution. Over here we have our canvas and for the sample input, and we are to find the relationship between the coordinates and the x and y values of the coordinates and the x and y values of both corners. So if you look at the x value of the top right frame corner, which is 65 in this case, you can observe that this corner, this x value, represents this line over here, as this line is on the x-axis. So when this line is on the x-axis, we can see that this line is just after the rightmost point. Well, what's the rightmost point? Well, the rightmost point is 64.10. So we know that this whole line must be one after the rightmost point to make the overall frame as small as possible. So as you can see, the rightmost point, which is 64.10, also you can say the greatest x value in our input, which is 24, 34, 44, 42, 64. 64 is the greatest x value, and we know that the frame itself cannot be touching any of the dots, so this will be one bigger the maximum of the x value. So 65 can be derived from the max of the x values plus 1. And next we'll look at the y value of 79. Well, this 79 represents this line over here, since it's on the y-axis. And if you notice, we can take the topmost point. Well, what's the topmost point? Over here, that can be also named the greatest y value. So that is this dot over here, 24.78. Since 78 is greater than all the other y values, we know that this line must be just above the highest dot. So this can be derived from the max of the y values plus 1. And so we've just generated the coordinates for the top right frame corner. Half of our problem solved. Let's look at the bottom left corner. Well, this 23, how do we get this 23? Well, this 23 represents this line over here. Okay, if it does, we need to find the leftmost dot since this line exists just before it. Well, the leftmost dot is the same dot we used for this one, so 2478, this is the leftmost dot. And we know that this line exists just one before the leftmost dot. The leftmost dot can also be described as the smallest y value. So 2478, smallest y value is 24 since it's lesser than 34, 44, 42, and 64. And this can be described as the minimum of all the x values minus 1 since it's just before it. So that's the x value for the bottom left corner, and for the bottom right corner y value, bottom left corner y value. Well, let's look at the dot at the bottom of all others. Well, that's 64 and 10. This dot lies beneath all others. And we know that this 9 represents this line over here since it exists on the y-axis as a horizontal line. So this 9 must be just below the lowest dot. Well, the lowest dot is 64 and 10. Well, that means the 9 is just below this. So this 9 can be derived from the minimum of all the y values minus 1 since it lies just beneath it. So using this, we can code up our solution over here. So let's start by getting all our input. So the first line of input contains the number of drops of paint, so that's n. And let's have two arrays, one array consisting of the x values and one array consisting of the y values to quickly find the max and min of all the x and y values. So we'll call the array with all the x values points of A and all the y values points B. They're both arrays. Now the troubling part of this question is this is given as one string. So we have to parse this string and separate the numbers with the comma, since after the comma it must not be misled as a space. The 6 is right after the comma. So we'll start by iterating over the n number of points. So we can do that with the loop. And let's read the whole line as a string. So we can do that as such. So x equals input the whole line. And now we have to iterate x and know when to add to know which digit belongs to which number. So first we have to remove the new line character at the end of the string. So we can do that like so. And next we're gonna have two strings representing the x and y values. So that's gonna be A and that's gonna be B. A being the x value and B being the y value. And now we're going to iterate x. So for character in x. Now if this character is the comma, we're going to have a boolean flag. We're going to call that s. So we're going to set that to true. And as soon as we visit the comma, we're going to set this boolean flag to false. So we know that we've just finished iterating over the first number, and we would like to iterate over the second number now. So if c equals the comma, then we know to set s to false. And now we need to know when to add to the b value, the b string, and when to add to the a string. So if not s, this means we've just visited the comma. That means we've done the first number, we've just visited the comma. Now we have to iterate over the second number. So if not s, this is another way of saying if s is false and c is not equal to the new line character, just in case, and c is not equal to the comma. Then we know to add this to the b string. Otherwise, we add this to the a string. Now that we've done this, we can convert a to an integer because it's still a string as it's now, and we can convert b to an integer also. So we can do that here. Next, we can add the a to the points of a array and b to the points of b array. Now that we've done this, since our objective to find some of these coordinates is to find the maximum value, the minimum value, what we can do is we can sort both of the arrays. So we can do that like so. Now that we've done that, we can start printing our output. So our output will consist of strings. So now to find the bottom left corner, let's go back to how we thought of it. So we need to find the minimum value of x minus 1 for the x value of this. So this can be the first index, since we've already sorted the list, and since we have to subtract 1 to the corner, we'll do that. And we need to add the comma, since we're outputting it in the same format. And now we need to add the y value, so that'll be string, and we need to find the smallest y value, so that'll be points of b, the first index, since it's the smallest y value, and minus 1. So we've just generated the bottom left corner's coordinates, and we can generate the top right corner. So as you can see, the top right corner was generated by the max value of x and plus 1 and the max value of y plus 1. So here, to access, since we've already sorted the list, the last number in the list must be the largest value. So to access the last number in the list, we can access index -1. And since we have to add 1 to both of these, we can do that. Next, add the comma. And then now we have to construct the y value of the top right corner. So that's the max of y plus 1. So we'll do that. So that'll be points of b minus 1 plus 1. And we forgot to add the comma here. Okay. So this should work. Let's try the first sample input. 5, 44, 62, 34, 69, 24, 78, 42, 44. Yep, it generated the right coordinates for both the sample input. And so this was solution for problem J3 of the CCC 2020 contest, Art.